In this new video, we will see how to interact with Prolog programs. So consider these two facts: train Milan-Paris, train Paris-Madrid. The first fact states that there is a train that connects Milan and Paris. The second fact states that there is a train that connects Paris and Madrid. How can we interact with this program? First, we need to install a Prolog interpreter. There are many free interpreters. SWI-Prolog, that also has a web interface called Swish, SWI-Prolog, Prolog, and so on. For this example, they are all equivalent. We will adopt SWI-Prolog, since it also has a web interface where you can easily reproduce these programs. As first operation, you write the two train facts into a file called, for example, train.pl. If you use a web interface, you can just write the facts in the web page. Using SWI, we can open the interpreter from the command line with the command SWI-Prolog. Once the interpreter is open, we can load our file with open bracket, open square bracket, train, close square bracket, dot. The final dot is important. You should see something like this. So after writing down open bracket, train, close bracket, dot, you should see true. The pair of symbols, question mark, dash, states that the interpreter is ready for a new command. We can now make a request to the interpreter. Actually, this is our second request, since the first is the one used to load the file. A request to the interpreter is also called query. For example, is there a train between Milan and Paris? In code, this translates into train Milan Paris as our query. If we ask this to the interpreter, we'll get as answer true. So it's true that there is a train between Milan and Paris. Let's try another query. Is there a train between Milan and Madrid? So train Milan-Madrid. False. So it's false that there is a train between Milan and Madrid. And this reflects the closed word assumption. So what is not explicitly stated is false. Another request. Is there a location that can be reached starting from Milan? In code, train Milan x. So now we introduce a variable x in our query. And the interpreter will look for all the terms that can unify with x. So in other words, we look for all the possible x's that make train Milan x true. So in this case, a fact into our program. As a result, we get x equal to Paris. Note that the symbol equal is not used to perform arithmetic sum. We now add a third fact into the program, train Milan-Rome. Our program looks like this. So train Milan-Paris, train Paris-Madrid, train Milan-Rome. If we ask again train Milan-X, we get still x equal to Paris. However, you can see that the interpreter is not ready, since it has not printed the dot after Paris. This means that can be other possible solutions, or in Prolog terminology, there is a choice point open. To retrieve the other solution, we can press semicolon. The result will be, after x equal to Paris, x equal to Rome. So both Paris and Rome are two possible solutions. We now swap the facts train Milan-Paris and train Milan-Rome, and the program looks like this. So train Milan-Rome as the first fact, train Paris-Madrid, and train Milan-Paris. If we ask again train Milan-X, we get x equal to Rome as first solution and x equal to Paris as second solution. So what is the difference with the previous output? That Rome and Paris are swapped. Now Rome comes before Paris, while previously Paris was the first solution and Rome the second. What does this mean? That in Prolog, the order of the clauses, in this case rules, matters. So this is an important feature because for some programs, a different order of the clauses may result in a query that terminates or loops forever. Consider the simple extension. We add a new rule, connect AB, that is true if train AB is true. We can ask some query, and in this query, we will use two variables inside our term connected. So we ask for all the possible pairs that represent connected locations. So connected AB, the first solution is A equal to Milan, B equal to Rome, semicolon, we retrieve the next solution, A equal to Paris, B equal to Madrid, semicolon, there's another solution, A equal to Milan, B equal to Paris. So we get a list of all the connected locations. Finally, to exit this SWI-Prolog terminal, just press Ctrl B or write Alt. Here you can see some useful references, and in this link you can download the Prolog interpreter we have listed before.